You're looking at the only surviving wonder of the ancient world, built over 4,500 years ago, with no cranes, no computers, no steel. And here's the question that has haunted engineers for decades. Could we even build this today? Not just could we try, but could we match the precision, the scale, the sheer audacity of what the ancient Egyptians pulled off? Some of the world's best engineers say probably not. And today, we're going to find out why. Before we talk about building it today, let's understand what we're actually dealing with. The Great Pyramid of Giza, built for Pharaoh Khufu, contains roughly 2.3 million stone blocks. Each one weighs between 2.5 and 15 tons. The heaviest blocks, found in the burial chamber, weigh up to 80 tons. The pyramid covers 13 acres at the base, that's about 9 football fields. Here's what floors engineers the most. The base is level to within just 2.1 centimeters across its entire 230-meter span. The four sides are aligned to true north with an accuracy of 0.05 degrees. This isn't ancient guesswork, this is precision engineering. So when we ask, can modern technology do this? We have to ask three separate questions. Can we move the blocks? Can we place them with that precision? And can we do it within a reasonable timeline and budget? What modern technology can do? Okay, let's be fair to the 21st century. We have some serious tools. Modern cranes can lift hundreds of tons. GPS and laser leveling systems can achieve millimeter-level precision. We have explosives and diamond-tipped saws for quarrying stone faster than any ancient chisel team. We have GPS, satellite imaging, and digital blueprints. We even have concrete, which some Egyptologists believe the Egyptians essentially invented themselves. On paper, this sounds like we win easily, right? Here's where it gets complicated. A 2008 study estimated that recreating the pyramid today using modern methods would cost roughly 5 to 10 billion US dollars. Some estimates go as high as $20 billion when you factor in logistics, labor, and safety compliance. That's before we talk about one massive problem: supply chain. The limestone came from quarries right next to Giza. The granite for the inner chambers, transported over 800 kilometers from Aswan. Today, closing roads, getting environmental permits, and moving millions of tons of stone through a modern city and across a river that alone could take years before a single block is placed. Where modern technology struggles or fails, here's where it gets really interesting and where engineers get genuinely humbled. Problem number one: precision at scale. Modern construction is precise, but it's designed for steel, concrete, and standardized parts. The pyramid used irregularly shaped limestone blocks, each one slightly different, and they still achieved near-perfect alignment. Our laser systems are more accurate, yes, but fitting 2.3 million unique, rough-cut stone blocks together with that precision? That's a human problem, not a technology problem. Problem number two: the interior chambers. The grand gallery inside the pyramid is a corbelled ceiling masterpiece, stones stacked in a specific way to distribute enormous pressure without collapse. No mortar holds it together, just geometry. Modern engineers have struggled to fully explain how it was designed, let alone replicate it at that scale. Problem number three: time. In 2001, a team of Japanese engineers attempted to build a small-scale model of the pyramid using ancient methods. They failed. They then switched to modern machinery and still struggled with the logistics. One researcher estimated that with modern equipment working 24/7, building the full pyramid could still take 5 years. The Egyptians did it in 20 with human hands. Problem number 4, maybe the biggest one, is the unknown. We still do not fully understand how the ancient Egyptians moved those 80-ton granite blocks from Aswan to Giza up the Nile and then lifted them 60 meters into the air. The leading theory involves water-lubricated sledges, ramps, and an organized workforce of up to 20,000 people. But there's no consensus. If we can't fully reverse engineer it, can we truly say we've surpassed it? So, can we build it? Honestly, yes, probably. Given enough money, time, and political will, modern technology could assemble a structure that looks like the Great Pyramid. But here's the uncomfortable truth. We would have massive advantages the Egyptians didn't: explosives, cranes, computers, trucks, and it would still be one of the most difficult construction projects in human history. The ancient Egyptians had none of those advantages: no diesel engines, no steel cables, no GPS, just copper tools, wooden sledges, rope, water, ramps, and an organizational system so sophisticated it makes modern project managers nervous. So could we build it? Yes. Would it be harder than we expected? Absolutely. And would it be as impressive as the original? Not even close, because they didn't just build a pyramid, they solved engineering problems we are still studying. They managed a workforce of tens of thousands across decades without a single computer. And they built something that has outlasted every empire, every war, and 4,500 years of time. That's not just ancient engineering, that's genius. What do you think? Could modern civilization actually pull this off, or would we underestimate it like every engineer before us? Drop your answer in the comments below. If this blew your mind even a little, smash that like button. It genuinely helps the channel and it tells me you want more videos like this. I'll see you in the next one.